Hey everyone, thank you so much for watching the Weaviate podcast. I'm super excited to welcome Charles Frye. Charles Frye is an educator at Full Stack Deep Learning, and Charles is someone who I've been following along with just, for me, it feels like my entire deep learning career. I've always been seeing what Charles has been posting on Twitter, and I always feel like I've been learning things from Charles. So I think also just the timing of this podcast is perfect because full stack deep learning, and we have all these new tools, vector databases, large language model APIs, what has happened with zero shot learning. And I think this is going to be such a great podcast of covering what is full stack deep learning now, like MLOps, and then full stack, like how we usually use the phrase full stack in software engineering, and how has all this evolved. So Charles, firstly, thank you so much for joining the podcast.
Yeah, thanks so much for having me, Connor, and thanks for that really kind introduction.
Awesome. So maybe before we kind of dive into it, could you give listeners more of a background on just like how you came into deep learning and sort of your personal journey?
Yeah. I came into machine learning and deep learning through a path that's increasingly deprecated these days. I did neuroscience and biology first. In undergrad, I did some research on giving people MDMA and asking them how they felt, and shooting lasers into mouse brains to see what the patterns in their biological neural networks look like. But then when it was time to look at doing a PhD, I looked around and it seemed like the ML world was really picking up. This was 2014 or so. Sort of the early applications of convolutional networks to really hard computer vision problems. And that looked like it was going to be like successful in the coming decade. And so I did a pivot and did a PhD in the neuroscience department at UC Berkeley, but studying artificial neural networks, studying initially some like applications to neuroscience, and then eventually kind of the mathematics, the optimization of neural networks. And then from there, from the PhD at Berkeley, have gone on to kind of end up in this role as an educator in the ML and deep learning space, sort of sharing ideas to research and how and sort of combining them with ideas from engineering and the development of applications. Initially at Weights and Biases as kind of like a educator developer relations kind of person, and then now at Full Stack, teaching teaching people most recently about how to build stuff with large language models.
Yeah, amazing. And I think also to clarify for listeners, full stack deep learning is kind of the key conversation topic and also the actual name of this course, which is
Got it.
awesome. And yeah, that is coming from a PhD in neuroscience at a school like Berkeley, and then coming in. That's just so impressive. And I think it's also interesting. I mean, maybe I'd like to stay. I think this would be a great transitioning topic because your background in weights and biases and exploring convolutional networks. The way I understand weights and biases, and I'm sure you're going to help me with this, is like this kind of hyperparameter tuning. Because I remember in the early days of training convolutional networks, like the learning rate, batch size, how many layers, the number of hidden units, all of this was so sensitive, and it was about finding this perfect combination of these things. Maybe quickly explain a little more about your perspective on MLOps at weights and biases.
Yeah. So definitely that was my view of it when I kind of like first came across it. That was something that really stuck out to me, the sort of like hyperparameter sweeping stuff. But as I like worked there and saw the product develop and saw the use cases for ML develop, like the thing that really mattered is monitoring and observability um, for experiment for the like experimentation phase of building an ML powered product. I think they've like expanded since I left like 2 years ago, and they recently announced a production monitoring beta, so it's not just for that. But the thing that I saw was this like with a small amount of instrumentation, a few lines of code, being able to get like system metrics, model metrics, all of that in one place, alongside with like what code was I running. I remember I ran into a distributed systems like Heisenbug, like a bug with a bug that sometimes happens and sometimes doesn't, because distributed training is just not deterministic, or is not deterministic unless you've spent all of your time engineering it to be so. um, and uh, and ran into what turned out to be a Heisenbug, a random bug. But I wouldn't have believed it unless I could compare two weights and biases runs right next to each other. This was the state of the disk. This was the state of the disk. they're identical. One has the bug, one does not have the bug. So that kind of like that's the sort of like software engineering, like bug smashing kind of side that bleeds into all the way up to the hyperparameter tuning, being able to see what happened, what your configurations of those hyperparameters were, and what the downstream results were.
Hmm. Yeah, absolutely fascinating. And we're certainly diving back into monitoring and observability, the topic, and distributed training, the topic. But let's set the stage for our listeners of, full stack deep learning. Maybe currently I understand, we're thinking about this kind of like data loaders, vector database, retrieval augmented generation to large language models. How do you see kind of the
Mm-hmm.
most common, end to end stack for building deep learning applications?
Yeah, that's a great question. So we originally had the full stack deep learning course, and actually, Josh Tobin and Sergey Karyev, my fellow instructors, put that together when they were grad students at Berkeley, and that course treats full stack as meaning I can train the models and I can like put them into production and then maybe close the loop and take insights from production and turn them into stuff that is used to train the model further. So it's sort of like in like Andrej Karpathy's vision of the like data engine at
Mm-hmm.
Tesla, where it's like you like collect data by the models being out there in the world that gets added to your training process in some way, either as part of evaluation or directly as something you calculate gradients with. Um, that the full stack deep learning engineer envisioned in that class is the person who can cross that divide or sort of go through that entire loop. So being able to do enough PyTorch and GPU training and distributed training stuff to work at a reasonable scale. Maybe not able to implement Megatron LM from scratch, but at least capable of consuming that. All the way up to putting something in a product and understanding what makes it a good product versus a not good product, and that everything that comes in between that. With large language models, the full stack developer actually starts to look maybe a little bit more like a full stack web developer, where a full stack web developer is somebody who can design a user experience, but can also like talk to databases and can talk to external services, and so can build like something that looks like a more like a web application. And at least for now, when so much of the capabilities are in models that are trained by somebody else, available as a service, don't require fine tuning, and only require like adjustments to prompting or adjustments of program and control flow around them. The role of that beginning part, that part that looks more like training models, that looks more like thinking a ton about PyTorch Lightning, Hugging Face, that part becomes a
Mm-hmm.
little bit less relevant. I'd love for it to all come back together again in the coming
Mm-hmm.
like year or two as we get better open source models, as fine tuning returns, as maybe even training from scratch in certain domains returns. I think we'll see that come together again, and then the full stack is now um, once again all the way from the GPUs to the databases to the user research and back.
Amazing. Yeah, that's kind of exactly what I'm hoping to kind of
Mm-hmm.
figure out in my understanding is how this can come back to that and how the new things can still relate to the old ways of thinking about MLOps. And so beginning with I remember a quote from one of our earlier podcasts with Chris Dossman. This was back when it was just GPT-3, and he described it as it's the perfect MVP tool, like minimum viable product. You just plug it in and you can see like what this could look like, because you mentioned like the data engine that Andrej Karpathy describes. To a lot of people, that's a lot of overhead to just get running with that, right? Like,
Mm-hmm.
so maybe we can just stay on this a little more. Like,
Mm-hmm.
usually to start building something with deep learning, had a data collection task, like a wildly difficult data collection and labeling task.
Mm-hmm. Yeah, I totally agree with that. I think these foundation models are clearly extremely good at building demos because now my Twitter timeline is 90% demo. And then there's like a gap to get to the final product. And I think One of my favorite examples of this came from Nat Friedman talking about the development of Copilot. He said they like stood up like 4 different like distinct language models for coding, with inside VS Code / GitHub. So 4 distinct products that like in a weekend. Like they tried autocomplete / IntelliSense, they tried like a chatbot type thing, and they tried like a PR bot type thing. And they got all of them to like MVP extremely quickly. And then there was like an extended period of turning them into like a sticky actual product. And the only one that actually made it that far was Copilot initially. They're going further with Copilot X now. And I think that's like illustrative. I think it's kind of common in the development of applications that MVP is easy and the rest is hard. With foundation models, I think part of what makes that eventual development into user product hard is that eventually you're going to have to get to the point where you have unique data that is driving unique model behavior. And for a long time, maybe there were fewer even demos because it was harder with the original GPT-3 API to like include context. And the patterns hadn't really developed. And now that we have this clear pattern for injecting into prompts via retrieval, or injecting into the model's generations via tool use, we now have ways to, without training models and without really needing to have to set up a full model creation pipeline, let alone like an actual data engine, you can get a much better product. And that starts to fill in kind of the middle area between just prompting to like training a model entirely from scratch, based off of proprietary data or data specialized to your problem. So yeah, definitely see the emphasis on the kind of beginning part, but it's also still very much early days in the development of applications. We could find that there's just the right patterns that lead to prompted foundation models building the whole application themselves.
Yeah, I think from the first example you gave with trying out 4 different code completion models, I think that's the stage a ton of people are in right now, where you're trying MPT 30 billion, Alpaca, Vicuna. You're kind of rotating out these cheaper inference models. Which one of these will work for my
To be clear, there it was different products, right? The same models were being used underneath, like same model family. And of course, they had a problem of deciding like which model to choose, and they ended up going with a small, fast model for autocomplete, because in autocomplete, aka the way Copilot works, it doesn't matter if you're wrong because users will just ignore your suggestions, and people are used to ignoring autocomplete. They're used to ignoring IntelliSense. Whereas if you're a chatbot, like people don't like being told wrong things. If you're doing a PR bot, people don't like reviewing PRs that turn out to be like fatally flawed, and so the like quality needs to be really high. And so that was their model evaluation problem that they had there. But that's like nested inside these like, what even product are we building? Are we building this? Are we building PR bot? Are we building a autocomplete? And that, key takeaway is the MVPs for all of those were easy. The products, some of them are still under development years later.
Yeah, it reminds me of like the early days of like when Jasper started gaining popularity, and I think Facebook, they started having papers where it wasn't about just the writing assistant wasn't just about writing more text, it's about like editing your text. And we mentioned like how exactly do we want these language models to interface, and I think that's the question now with LangChain, and that's what's being discussed. So something you said earlier, I love this quote when you said unique data to achieve unique model behavior. And then we discussed better retrievers, and we're getting into, of course, our Weaviate interest is this like retrieval to the large language model. And so this is the kind of the question that's on my mind more than anything else, is to achieve unique model behavior with our data. We've plugged it in, we've figured out the user interface, we've started collecting data. Should we fine tune the retrieval models or the language models or both?
Yeah, that's a great question. Fine tuning the language model is a little bit more challenging, and there's a little bit less to go on in terms of what it means to make it better. Like, you might need user preferences, you might have some like cases where you have specific behavior that you want, but even despite the advances in efficient fine tuning, I still think that's going to be challenging. And then you have a model serving problem, It's a lot easier when there's only one version of a model. You much simpler version system. Um,
Yep.
but for retrieval, I think of that as like a very broad problem, right? This is like a search or retrieval problem where there's data that lives in some big, slow thing like a disk or a database, and we need to load it into some like very memory sensitive place. And that memory sensitive place is the like context window of the large language model. And so retrieval via embeddings is one very good way to do that. It's a good way to do that because retrieving information from a vector is how a transformer computes, and so it's likely to be the case that the things you calculate with vector similarities with dot products are likely to be similar to what the language model will do internally. But that is just one of many ways to get information out of a large store and into the small hot cache where it is needed. And so, yeah, so I see that as like probably the first, like the 0th place to start is like your data, your pre-processing. As always, nobody wants to talk about it, but that's the place where you should spend your time. How do I parse these documents? Am I pulling garbage out of my data store? So just like classic ELT and data validation problems. So definitely that's step 0. And then it's like look at the retrieval process of that, increase its quality. Probably maybe it involves passing some gradients through a retrieval model, but honestly, I think you can do a lot with like metadata filtering and other classic information retrieval techniques, and then those things that improves the inputs to this downstream model.
Yeah, definitely a lot to unpack. I think maybe if we can just stay on the last topic of the metadata and how much you can
Mhm.
bootstrap. When we originally released hybrid search, where we're combining, say, the zero-shot OpenAI models with BM25, and then
Mhm,
maybe
mhm,
you could also say re-rank that with a zero-shot cross encoder, which could also kind of push it a little further. And it's like,
mhm, mhm,
yeah, maybe you can just kind of get pretty far with these zero shot models when you orchestrate it like that, especially because now the large language models, you can kind of prompt them with the filters that they can add to make it filtered vector search, or you could just
mhm,
entirely separate your data out into different indexes and ask it like which one to search. In Llama Index, they call that the composable indexes. And
mhm.
yeah.
Yeah, yeah. So there is kind of maybe two distinct patterns. One is retrieval augmented generation in the like more classic sense. Feels silly to call something classic that's only like a few years old, but we'll call it classic. Um, but yeah, there's like a classic version of it, which is loading information into the transformer at like boot time. You might think of it like you're starting to run your transformer on its on the context it's running, and you're just saying, what do I need to load into that thing's like RAM once the program starts running? So that actually it's really more ROM. What do I need to load into the ROM of this thing for it to run? Like this is like Commodore 64 style. Like I'm just like I'm punching the tape and saying like, this is the documentation of the library that I want you to answer a question about. And that is the distinction there is that part we think of that as like separate from the behavior of the language model, and that it's amenable to like software 1.0 or traditional ML and IR techniques. And then the other direction to go is to say, no, language models are like reasoning engines. Language models are executors of like complex program flows, and retrieving from information store is just a program flow. So like, make it this is like retrieval via tool use. And I can see there being applications where one or the other is more valuable. I think the more constrained your application is, like the less open domain its questions are, and the more straightforward the questions are to answer once you have the context, the more it looks like pure retrieval augmented generation. Um, and so, like for the main little chatbot retrieval augmented generation application that I run, which answers questions about our course material and about language modeling papers. The goal is for it to just be a searcher of that stuff. And so the open endedness is a little bit less, and so there's less need to be like, oh, like tell me which of these like 50 possible tools, or maybe run a Google search to get information, etc. But for very open-ended, maybe things that are starting to tickle the edge of being like an agentic system, then you might want
Mhm.
something where retrieval is just one of the many tools that the language model has access to.
Yeah, I think that's just completely brilliant is thinking about retrieval as a tool use compared to, well, so I think to break this apart a bit, I think you mentioned several times that transformers attend over vectors. And, I think our listeners, probably most of them, are aware of neural architectures and how they work generally. So, we have, say, 12 layers of transformer. And so one idea is instead of just retrieving to put it in the input, you retrieve vectors to put it in, say, layer 10 out of 12 or 8 out of 12, and it differentiates on the memory. You could have ideas where you differentiate through the retriever, or even just you keep that as semi parametric, and you just go through the 1 to 12 with it injected into 8. So that kind of architecture, to me, that diverges from just retrieval as tool use, just because I don't see how any other tool could be put in the middle of an arc. And then I think it's extreme, like, yeah.
Yeah, I would say that that sort of retrieval augmentation that is baked into the architecture, which goes back to at least retro for this crop of language models, and I'm sure there's some BERT paper that that did it way earlier, and there's a Schmidt-Huber paper from '93 or whatever. But that style of doing it, where you are tightly coupling the internals of the model and the retrieval system, I would believe that for narrow tasks, you can differentiate that and then like get really high performance for really low model sizes and really quick latencies. But the that like tight coupling there makes it harder to be like, oh well, now I want to do a LoRA fine tune. It's like, well, how does the LoRA fine tune interact with the retrieval thing? And it's like, oh, I want to use shortcut transformers. I read this thing about shortcut transformers where you can stop 4 layers in and then like predict the next token immediately. And it's like, oh well, how does that interact with it? So like the more you start to adjust the internals versus treat this thing as an interface where either you're interfacing with its inputs or its outputs like are used as inputs to your interface. The more you like break that abstraction and start injecting into the internals of the model, the more fragile the system becomes, the like harder it is to adjust. And right now, at the very least, there's just so much open field in terms of where you just think in terms of those external interfaces. So for it, like until I see like many papers demonstrating or many applications demonstrating that that's like gives you 10x 100x quality at decreased latency or something, I would strongly recommend like not opening that Pandora's box and sticking to the interface.
Yeah, it would have to be produced by something like an open AI. I mean, I think just the last 2 days we've seen two massive fundraising announcements. I think I think Reka Labs Inflection AI raised like 1.3
Mm-hmm.
billion, which
Mm-hmm.
is funny enough the exact same number data breaks. So that's
Yeah.
kind of funny. And so yeah, it would have to be someone producing a foundation model that comes with the retriever end of it. And yeah, LoRA, early
Yeah.
exiting, definitely topics that we're going to come back to. But first, I want to stay on this tool use kind of concept a little further. So I was
Mm-hmm.
in Berkeley as well last weekend. Just didn't go there. Just I went there to see it, and I met the authors of Gorilla. And I thought Gorilla is a large language model that's been fine tuned to use particular tools.
Mm-hmm.
So it's like it's still black boxy. Like it's not. We're not talking about putting the a latent space of this tool into the middle of the transformer, but
Mm-hmm.
we're talking about giving it some examples of how to search, or more like how to use like GitHub CLI to like. That's one of the examples that I was just like, wow, that's pretty cool. Like this whole like where the tool is to execute code or to file a pull request or to review another pull request,
Yeah.
like pulling all those levers. I find that to be so fascinating. So that kind of idea, like I remember WebGPT had like
Mm-hmm.
search
Mm-hmm.
actions, kind of like,
Mm-hmm.
discrete black boxy kind of how to use it. What do you think about that idea? Like fine tuned to use tools kind of.
Yeah, I mean, I think that we have already seen it. Like, if you asked me that question a month ago, I would have said, oh, geez, what we really need is a highly capable foundation model that has been fine tuned on some kind of tool use pattern And to be honest, what tool use pattern would I like? I'd like something that looks a little bit like an open API spec. So this is something I spent some time working with the folks at Speakeasy who do API tooling development and just sort of like helping them understand the LLM landscape and what that could mean for them. So I got super into this a couple of months ago and learned a bunch about the sort of API tooling world. But it's a way to clearly describe what is available via an API. If you've ever used Fast API and you've seen that little like free docs page that you get, if you use Gradio for a long time, they also showed you that docs page. That it's the like brightly colored thing with like different types of requests and paths available. It's such a well specified thing that you can build automated tooling off of it. And so like I would have said a month ago, like, yeah, something that's like close to open API spec as like how you describe your tools, and then like the model knows how to produce a request that goes into that API. And so you fully separate out the execution of the tool from the model, and you train the model how to work with that specification, which means you aren't training it how to use a specific tool, right? Like Toolformer and Tom both kind of are like, oh yeah, let's fine tune some model to like know when to use a calculator and know when to search Wikipedia, right? And React as a pattern is also like, let's use few shot prompting examples to describe the format for a tool, and then the model will try and pick it up. And both of those approaches work okay, but they're not super flexible. And like what you want is like a flexibility of tool use with model fine tuning, right? So React has a lot of flexibility at the cost of token budgets, and then a little bit of reduced reliability. Like a Toolformer pattern is going to be like extremely reliable, but you have to have examples and you have to fine tune on a specific tool. So fine tuning on a tool specific on like broad examples from a tool specification that happens to also be a spec broadly used by people to describe services that they are making available seems like the right move. And with JSON schema powered function calls, OpenAI has done exactly that. And so there's like an incredible opportunity here with tool use that I think, we're just beginning to scratch the surface of, even the people who have been thinking about this like constantly since it came out.
Yeah, that was such a great Torval. I love how you brought back Toolformer. That I think if you're mentioning Gorilla, it's good to cite that one as well. And then, yeah, the React tool use and maybe the OpenAI functions thing. You mentioned your experience in the Open API specs, and I do find that whole JSON formatting of functions, the universal interfaces, and what OpenAI has accomplished with that. I really like that. But if we could transition just one, I want to talk about a specific kind of tool, which is this kind of like text to SQL kind of idea where you would fine tune a model to generate SQL queries. I think just if we could stay on this little microcosm of just this one example and think through, like, because to me it sounds like, and it's something that appeals a lot to Weaviate, and is like, like having there's this paper called Tiny Stories where the headline of the paper is how small can we make these models, and they still are able to talk to us. And so it's like, if we could have a 30 million parameter model that we could just wrap up in a Docker container, serve on a CPU, I think you could probably Onyx and make neural magic, make it run fast. But like that kind of thing of something we could put into Weaviate, and I'm sure there are other examples out there in other kinds of software.
Yeah, I definitely think. So the flow that I just described is very much something that you need a large scale model to handle, because you're going to be picking up semantic information from the natural language in a spec. It's sort of like it's reading documentation while also kind of like parsing the contents, and then we're generating this like in this particular format, and we probably also want to be able to like interact in natural language as part of building those things. Yeah, so that's very like large, very capable language model territory. So you're expecting to get that from a foundation model provider. But if you have a specific domain where you want to use a language model, but you want it to like sort of interact with symbolic software more directly, then you can, and that domain is fairly narrow. You're only generating SQL, you're only generating
Mhm.
Python code. Then maybe you can get away with much smaller models. I would worry a little bit about, I think if you took an extremely large model and you somehow collected a trillion tokens worth of SQL and natural language paired with SQL, it's like, interesting to think what kinds of capabilities would you get out of that? Like, could you just ask it to write, to effectively like write your whole database, like as opposed to just like writing one query. Um, but yeah, that's definitely the like narrower tool use can involve narrower interfaces than just some like generic thing like OpenAPI or JSON schema or whatever, and can just be like, yeah, we want something that generates SQL. Will run that SQL.
Yeah, I mean, this conversation is really inspiring my interest to run this experiment where you would like use GPT for whatever to generate a big training data set to then distill the SQL thing into. I guess like
Mhm.
every input would take in the schema and the natural language question, like the kind of like special token separation like you do with like BERT and stuff. And yeah, I mean, I think because I don't know if we've had this kind of experiment where you scale the data without scaling the model and then into a narrow domain. I'd like to call that like generative data augmentation, some kind of phrase like that.
Yeah, definitely people have started to look at that. I think there's like with instruction fine tuning that which includes the like crop of South American camelid named instruction following fine tunes like llama, or sorry, like alpaca, vicuña, guanaco, etc. I think
Yeah.
we've run out. I think we're out of people will have to find a new mammal to name things after. But like that crop, if you look back even before that, people were looking at generating data with GPT-2, even GPT-3, to generate instruction type data, and have found that to work like pretty well. I forget whether the FLAN data set is constructed in that manner. It might not have been, but natural instructions and supernatural instructions both constructed in that manner. So there's like a proof of concept with one of the sort of like biggest changes with language models, which is the switch over from like modeling text to modeling responses to instructions.
Hmm.
So I can imagine that kind of like scale, like make a big data set with a capable model and fine tune a really small model. I can see that working pretty well in a lot of domains.
Yeah, I don't want to get too off topic, but yeah, when I first saw that, like, I think it was called like decision transformer. I think that's also a Berkeley paper where yeah, it shows how similar like medical treatment decision modeling is to language. It's still like sequence to sequence. The key difference being the sparse reward compared to like
Mm-hmm.
here's the supervision at every step. But here, so I think I want to stay. Earlier, we had mentioned this general topic of what I think is the biggest question in full stack deep in like, well, I say like full stack retrieval augmented generation maybe is a better phrase for it, but like, should you fine tune the retrieval model? Should you fine tune the large language model or both? And what is this? And so this is one topic as we're talking about generative data augmentation. We're talking about sampling data from large language models to train smaller models. So I
Mm-hmm.
love this idea where you use the large language model to generate a potential query for a document, and then that's what you use to supervise the training of the embedding models.
Mm-hmm.
I think it's so profound because, I remember in the early days of Weaviate, we were talking about like we were building site search. It was like a thing before. No, we have it now, but before people would troll us on Twitter and say like Weaviate doesn't even have search for their documentation. And so, so we are like, okay, how are we going to build this? And one idea was like, all right, let's everyone write 10 questions for each of the pages, right? And that's how we're going to train our embedding model. And so that kind of like it solves the data problem of the language model can write queries potentially.
Yeah, and I would say that it solves the cold start problem for data is a better way of thinking about it. It's
Hmm.
like your data engine needs a cold start, and the language models are one really good way to do that. They might, I've a lot there's this like emerging intuition about the highest capability language models like GPT-4 and Claude, that they are like a high percentile crowd worker. It's like
Hmm.
so actually better than your median crowd worker on many tasks. And but with crowd workers, it's not like people just like hooked up a direct data stream through Kafka from Mechanical Turk that just like spat out data that went straight into tensors and turned into gradients. Like, there were systems around it, and there were end user data and like data that you purchased, dog fooded data, like you described for Weaviate. Those were all additional sources. And so language model generated content is an additional data source. It has its own issues. Like language models really like language model content, so they might give you rosy evaluations of your performance on that. And I think you might lose. You're going to sample well from the like high probability regions of documents, at least high probability regions of documents produced on the internet that end up in these pre-training sets. When the like long tail of requests is going to be really challenging. I know Joe Bergam um, at Vespa has talked about how there's like the bulk of queries and the long tail of queries, and the long tail of queries like ends up being nearly as important as the bulk, because in the same way it is for requests, right? You look at your requests, you look at you're running an API, and you look at your requests, and you're like, 99% of my requests are resolved in 100 milliseconds or less. That's great. Like, all 99% of my users are seeing a snappy website. And it's like, no, hold on. 1% of the time while you're doing some task in this website, you hit something that takes maybe 5 seconds. And a user like that, even if it's sampled at random, if a user is like taking many actions, they're going to see it pretty soon. And so similarly, even though like the long tail of potential requests is rare, thought of as individually, it might be every user has a request that they make that's in the long tail. And so language models in generating data are likely to generate things that look like the bulk of queries, not things that look like the long tail. And there's some research on this cursive recursion that has modeled this phenomenon and shown it empirically. And that's going to be a problem for getting to that sticky, really high quality product. And so I would suspect like actually fully solving the problem of needing data to train models is always going to involve a data engine with many diverse sources, not just ask GPT-4 to generate you 100 new data points.
Yeah, I love that, and also that cursive recursion. That's an awesome title for a
Yeah.
paper. Yeah, I mean, I give a quick shout out to a previous podcast with Professor Laura Dietz on perspectives of using large language models to annotate relevance judgments. That's an awesome paper, and also I've got this haystack cup here. Unfortunately I put it in the dishwasher, and that took it down a little bit. But they have this tool called Cupid for labeling query. It's just like some interesting things for people listening, maybe who'd be interested in referencing it. But yes, this long tail thing, this is so interesting. And I'd hate to I don't want to get too off topic with generally this kind of retrieval augmented generation thing, but like I've kind of thought of like class imbalance and the inability to perform well on minority sets of data is kind of the crux of self-driving cars. I know I'm pivoting topics pretty heavily,
Yeah.
but do you think I've started to think that self-driving cars with deep learning will never be realized because of this problem?
Yeah, I definitely have entertained that hypothesis in the past, and now there's probably a video of me on YouTube somewhere saying that. But uh, there's two things there. One is that empirically, I can get in a cruise automobile and take a ride across San Francisco with no driver. It like I can pay money to do that, and so it's kind of happening. Um, and there's lots of deep learning involved at lots of different parts of the stack. There's also lots of expert systems involved, but and lots of traditional control and linear quadratic regulators and stuff. But there's deep learning in there for especially for perception. So it is happening. It took twice as long as people expected, typical for an engineering project, and took a lot more capital infusion than people expected. But it seems to be happening. I would say there are still long tail issues, and people complain about behavior of the cars, and that is Like resolving that is still a hard problem. I would say that language maybe helps a lot with this long tail problem in that I don't know if there's like a figure in the GPT-4 white paper from OpenAI that shows how multimodality helps. And it's like asking it to describe the content of a picture. And the picture is of a man hanging off the back of a taxi cab doing ironing. And if you are a self driving car and all you ever do is like consume LiDAR, you will drive many, many billions of miles before you encounter a man hanging off the back of a taxi cab doing ironing. And so, like, or even, yeah, like you might not even encounter any ironing, for billions of miles. But if you have if a component of the stack that's part of the perception is trained on a broader data set, like the breadth of the entire internet, hundreds of billions or trillions of tokens, then it has a chance to find out about all these smaller concepts that can be composed together, and also to like knock out further into the tail the things it has never seen before. And so, yeah, like that I think will help with that kind of problem. I think there are problems with using really large transformers, in a car, from power consumption and to like latency and all these other things. But at least that feels like an in principle way to help a lot with the long tail problem as it appears in self driving cars.
Yeah, fascinating. I definitely could talk to you for a while about self-driving cars. It's so interesting, but let me kind of bring this back to kind of search and like people building chatbots and things like that. With our thing is like, I guess I think about this like a lot of these large language models, they've been trained on like, internet scale text or maybe like Wikipedia, the breadth is enormous. But and then I think
Mm-hmm.
about the fine tuning, like, if the, full stack Discord is a particular pocket of that space, right? Like to me, just the intuition is that it would make so much sense to fine tune it to put it over into that space.
Yeah, yeah, definitely. I think the LoRA paper is truly incredible. The low rank adaptation paper from Microsoft Research. It's like people are aware of this like fine tuning method, but they like and they're aware that it's good and they should use it or whatever. But I feel like people haven't seen the paper has a bunch of really great insights in it, and one of those one class of insight that's in it is that they actually like analyzed what the hell is going on in these fine-tuned layers, like what are they doing.
Mhm.
And what it looks like from what they have in that little uh, more sciencey section, it looks like what they're doing is reordering the like eigenvalues of every matrix. So they're taking, like, loosely speaking, they're taking the concepts that the language model already has, the like operations the language model already likes to do, and re-ranking them and saying, no, actually, this behavior is really important, and this behavior that we used to think was important is less. So like, let's shrink our behavior in one direction and like increase our behavior in another direction. So like more so than say like discovering an entirely new direction to focus in. And that sort of explains how you can get really profound changes in the model's behavior without necessarily increasing their intelligence or capability, which is what we've seen from like Lima and the false promise of imitating proprietary LLMs paper, that you aren't necessarily making, and even the Guanaco paper, like you aren't necessarily making the model that much smarter by fine tuning it. You're just like changing the manner in which it produces outputs. You're revealing things that it sort of was already capable of doing, that was in the probability distribution over the vocabulary at the end, that was present inside of those big residual stream vectors inside the model, but was like relatively down weighted because it wasn't important during pre-train or wasn't important during RLHF and supervised fine tuning. But in your final downstream fine tuning case, it's super important to like use this particular style of diction or to like refer to a particular noun, and so we can just sort of pull those things out and reduce relatively other things.
Yeah, it's so there are kind of two things to that I want to pick apart. I mean, quickly, there's recently we had the Voti podcast, Stephanie Horbacheski and Gunjan Bhattarayi, where we talked about how you can put image embeddings into the latent space of like LLMs, and somehow that works. I mean, like somehow it's able to do that. And like mentioning the eigenvectors, so maybe for people listening, weight matrix, you take that matrix and you decompose it with singular value decomposition, like USV, that kind of thing. And then the eigenvectors are like that diagonal, and like the rank of it is like how many. So like the diagonal of this eigenvector is like how the important components of it. Thinking about projected and residual components is always a.
Yeah. I'd say the short version of that, the like very software engineering version of that, is that the eigenvectors define the independent things going on inside of a matrix.
Mhm.
So you could think of them as like a bunch of asynchronous operations all going on. And because this is linear algebra, each one has a different like weight on it, a different importance. And so
Mhm.
those are the weights of those eigenvectors. Actually, you know, for the real math nerds, these are all singular values and singular vectors, so I'm not committing a math crime here. They're real valued, and maybe even positive. But yeah, so they each of these little asynchronous procedures has an importance weight attached to it. And when I say that we're like re-ranking them, I'm saying that we take some, like, one of the processes was like simulate what Homer Simpson would say in this situation, and that's not that important in web pre-training because only a small fraction of documents on the web have Homer Simpson in them. But you do still need to learn it if you want to get to the quality of language generation that GPT-4 has. But if you're fine-tuning the model to sound like Homer Simpson, all of a sudden that process becomes really important. And so you increase its weight, you increase its rank. So that's a hand wavy, whiteboardy software engineer's approach to understanding what that means.
Yeah, it's so there's definitely applications of this in vector search as well. Like, there's this paper called HNSW Finger, and it looks like there is a lot of opportunities for us to look at, like, projecting vectors onto other vectors. But I do stay like I've always thought that like disentangled representation learning was just like an unsolvable problem. Like, even if it's the eigenvector where you disentangle the components of it, I don't know, like, because sometimes people, when you're explaining vector search to people, you'll say like this dimension of the vector says how much of Homer Simpson it is. This one says how much of this it is, and it's like, no, it's totally like entangled across the vector.
Yeah. And so yeah, the goal of eigenvector decomposition is to like find a basis in which, to sort of rotate the thing around so that you can actually see, oh, this is the Homer Simpson dimension and this is the plural versus not plural dimension or whatever. And there's been limited success in doing those kinds of things to understand the internals of transformers. But yeah, definitely individual neurons, individual components of those vectors don't seem to have a huge amount of like independent meaning. And honestly, I don't think you would necessarily want that to be the case. You can, if you try to store information in those like n dimensions, you're stuck with the n dimensions of your embedding space. And n is pretty large for a large transformer. I forget what it is for GPT-3, like low thousands probably, maybe 10,000. But like, like it's that number. And it's the amount you can store if you pick different dimensions to store different things is linear. If you relax that and say I don't want to have like n completely orthogonal directions, I just want them to be like mostly orthogonal to each other. I want their dot products not to be exactly zero, but I'll let them be like a little bit different from zero, and that I'll still consider that, or yeah, like I'll still consider that like those two unrelated vectors. Now all of a sudden you have exponentially sized memory storage. And so it's like what people have found from looking at transformer internals is that's what they're doing with that transformer residual stream. There's like, if you want to know what's in it, you have to look at every dimension and do like a dot product with some query rather than looking at some specific dimension to figure out whether a piece of information is like true or false or what value it has.
Yeah, well, I think without question, there's more. Like, it's so interesting. It's such a great topic, but I think like if we could pivot into maybe explaining LoRA a little more and how low rank adaptation works. So again, so you can take the weight
Mhm.
matrix and you can decompose it into eigenvector. Like, you can reconstruct the matrix from the decomposition, and so the idea is you can just update these the low rank projection with the fine tuning, and then you have like the sparse fine, and it's like the latest update in sparse fine tuning where to update like a 12 billion parameter. I don't know why I said 12, but like big model to you can update a subset of it, and then
Yeah,
it's
12 billion used to count as big, you know. Even the like Megatron LM paper I want to say is like low 10 billions in scale, but now that's like, oh, that's like a small fun open source model, 12
yeah.
billion.
But
Yeah.
yeah, I think something that you had told me about in our brainstorming session is this, and something for I think more casual, like people who are just kind of hacking together applications with Weaviate and the OpenAI API.
Mhm.
Is this idea that if the LoRA fine tuning thing becomes more accessible, one idea would be if we have a Discord chatbot, you have a separate set of weights for Connor and a separate set of weights for Charles, and so
Yeah.
on. What do you think about that idea? Can you tell me more about it?
Yeah, it's really cool. I think we don't have the infrastructure in place to do that. Like, and there's a bit of a bearish, so a bit of a bearish signal on that front. If you look at the image generation world, which I I spend a lot of my time thinking about the language modeling world, and that that's where I'm spending a ton of my time and thought. But I recently built like a little QR code art generator, and so I like checked out what's going on in stable diffusion world, and they have been productizing foundation models for way longer than the language modeling world has, because they had their moment of like broad accessibility earlier, right? We still haven't quite had our stable diffusion moment in language models, which is to say like an extremely highly capable model with completely open weights that can be run on consumer GPUs, like, and all of these like all these things. We're still just a little bit short. We need something as smart as Text-to-Vinci 2, but that you can run on like one 40 GB card. And so maybe even by the time this podcast is released, that'll already be true. Like, who knows? It could happen any second. Um, but yeah, so in this world, people have been building stuff, and they have discovered different uses for fine tunes and like control net as a way of like merging multiple fine tunes together. But so far as I can tell, they don't have anything that looks like that dream that you just put out there of like, I have one set of weights that's very small, megabytes in size, that adjusts the behavior of this language model for one user, and then I have another one equally small that I can hot swap in, actually with like a CUDA operation. It's just matrix math to swap out a LoRa fine tune. And then so like on the fly switch over, and now I'm doing it for a different user persona, a different region, whatever your approach is for segmenting out your fine tunes. Um, that doesn't seem to be the way things work. It seems like mostly people like download the entire weights for every model that they want to use, and that like even if they are related by some lineage. So it's a bit of a bearish signal for whether this is going to actually get adopted in the language modeling world. You need some kind of like shared manner of expressing where these weights should go, and making it possible to like git merge like one fine tune with another, or all these things that you would want to make it really good. So like right now, there are probably people doing that internally who've built some jank version of that, but there's no like open standard that everybody can use that solves that problem.
Yeah, I guess I think like there's certainly potential for that in the future. I guess for now we're seeing like you kind of do like role playing prompting or like personalized prompting where I'd be like, here's an example of how Connor writes his emails, kind of, and like, or like,
Yeah.
Connor likes basketball. Could you tailor this advertisement to Connor? And then it's like, hey, come play basketball. But
Yeah,
like,
prompting. Yeah, as always, prompting takes like 30 seconds to try and gets you 70% of the way there.
yeah,
So, like,
yeah.
yeah, and it works like retrieval augmentation works super well. And then like hammering down that last bit then takes you have to move over to using fine tuning. You have to move over to like redoing the pre training. Whatever. And uh, yeah, so that's like a pretty typical pattern. And so starting off with like per user prompts is a good way to at least start seeing, okay, what do users need before they prefer a user specific model to the base model. Or what are the right ways to break this down? Like what information is user specific versus what is generic? And maybe like you can imagine like a hierarchy of like you have individual users all the way at the bottom, you have a single model for all users all the way at the top, and then you have different ways of partitioning your users and having a specific prompt or fine tune or other kinds of different behavior at each point in that power set of partitions, and like figuring out what the right ways to think about that are with prompting is a great way to save yourself a lot of pain and time and A100 time.
Yeah, I mean, I think it's kind of coming into like it's like the grand arch theme of our podcast is like MLOps, full stack deep learning, and I think this is coming into this kind of monitoring and observability sort of topic with respect to like embedding space visualization, where like it's hard to just segment Charles and Connor, however many people, because we're so abstractly defined, but we have this like visualization of clusters. And yes, maybe just set the stage. How are you thinking about like, yeah, this cluster visualization? I think of it as just a super powerful way for people to start collecting data, and then for more people who are software who don't come from like training, who optimizing CUDA kernels, like people who are just trying to add it to their apps. I think this idea that you can start collecting some input output examples, start labeling them on what I like, what I don't like, and then maybe just see those colored green and red when you put those inputs back into the latent space. And I think these kind of charts, I think that's a huge middle ground for going from this zero shot RAG stack we're talking about into the MLOps world, the weights and bias, all that. Like, I think this middle part of just that, I think that could be a huge evangelist for this.
Yeah, I think I personally have benefited a little bit from that. Like I had a little for the Discord bot. I pushed it through tsne, actually using the like built-in version of it inside of weights and biases. Upload some vectors from the vector store with their metadata attached, and then just project them and look at them in 2D. And it immediately revealed that there was like a large chunk of data from some PDFs that looks like it's like mangled Unicode bytes, or like somebody like included their LaTeX program inside of their PDF in a weird way. And so it's just garbage. It's just like garbage, disgusting. It's basically a failure of my like data loading and validation pipeline to not recognize that that was not suitable input. And now because dot products are pretty good, like I'm not ever seeing that in production. Like I'm not seeing those getting pulled in and like mangling my context, but I'm wasting money embedding those. I'm wasting database space holding on to them. And maybe there is good information in there if I had a different pre-processing pipeline to pull that out. So that's like, that's the kind that like very base level insight that comes from not even full on observability, but just the like barest forms of monitoring, and the like barest forms of dashboarding and visualization. There's a ton of value to be unlocked there. And that's definitely what I saw when working at weights and biases, that it's just like just being able to see the GPU utilization really easily and being able to be like, wait a second, it's like way lower than it was 3 weeks ago. What the hell just happened? Like that will give you a ton of gains that going further requires you to do a ton of additional instrumentation and a lot of hard work that often is like not very long lasting and needs to be like adjusted and needs like constant engineer maintenance. And these like simple things like just take the vectors and tsne them and look at them every once in a while gets you a huge chunk of the way.
Yeah, it's just like when you're curating data sets for language modeling, you have so much data, you really have no clue what's in it. So this kind of Unicode clusters, and I've seen that for myself. It's a
Yeah.
pretty funny problem to see. I would love to transition into this topic of GPU utilization a little more. I
Hmm.
admittedly know very little about it, but this kind of like what, maybe if you could just set the stage with any topic that interests you, and we could go from there.
Oh yeah. I mean, I don't have that much super interesting to say about it. And now that people are mostly using things via, that story and that comment came from my time at Weights and Biases, and at a time when there was much less foundation model use,
Mhm.
and a lot more training and running things yourself. So I don't know that I have too much interesting to say there, except that if you've never run a profiler that gives you like both profile level stats and critically like a trace view for a GPU accelerated job, just like stop what you're doing and like get even just like an MNIST tutorial, run it, and then ideally also a model that you care about, you have running in production or that you're working on, just to like it substantially improved my intuition for what PyTorch was, what CUDA was, like what GPU acceleration means for neural networks, just to see this trace of like a flame graph type trace with for the CPU, for the GPU and its streams, and to relate that back to the kinds of metrics you might see in NVIDIA SMI or in weights and biases. It's something that web developers like don't even know how good they have it. Like they can be running their application in a browser, they click like 3 buttons, and all of a sudden they have a perfectly recorded, replayable visual trace of what happened in their program. And like that's a similarly awesome experience for understanding the browser, the DOM, the the event loop, like all the pieces that make a web application work. You can get a ton of insight from looking at those traces. Same thing applies to tracing your GPU accelerated workloads.
Yeah, that's been one of the, from joining Weaviate and seeing the inside of like a legit engineering company compared to like my PhD. That's been one of the big eye-opening things for me. I remember seeing those like stack trace graphs and thinking, what is that? Or it's like you're spending this much time on the distance computation, this much time like updating the end, like all this kind of stuff with the HSW. So with GPU profiling, do you usually look at, like, I know about like idle time between when you're kind of like sending the gradients and you're looking for the next like just batch of data, kind of pretty abstractly, but do you maybe profile it like layer by layer? Like how fine grained does profiling GPU utilization get?
Yeah. So the profiling tends to be like, here's the operations that you ran, like with some level of granularity. Here's how long they took, like on average, and here's like some quantiles. So that can be useful, but I find, and that is especially useful when you're like really knocking down like and just continuing to go and like make something faster and faster and faster. So that's very much a post product market fit kind of like, this is a really working feature and we're now spending 10% of our time running this workload. Let's try and get that 10x faster. It hasn't changed in a quarter. We don't expect it to change this year. Let's spend some time on it. With tracing, where you just see like a single or a small number of executions, that is more useful as like a thing you do anytime you're running something, because you can catch these very gross features that are like unintuitive about the behavior of your program. Just like as an example, like I was consulting with somebody and they were like, "Oh, take a look at my deep learning stack," and I like just quickly ran their model through this profiler, and it was like partway through their forward pass, the CPU stops, the GPU stops. There's this like giant block of like something is going on not in PyTorch but elsewhere in Python for like a third of every forward pass. And it turned out they were dynamically constructing a Python class on the forward pass. Just like, in Python, you don't often think that hard about like, am I dynamically constructing this class or am I constructing it ahead of time and then like, like referring back to that definition? It's like normally you don't have to, like, that's not slow enough that it slows down the execution of your program. But once you're in a hot loop, like a model training loop, 100 milliseconds matters. 100 milliseconds can be an eternity, even if, depending on what you're running. And so just like simply moving the definition of this class from like, oh, it's like dynamically constructed in the middle of the forward pass to, oh, we construct it ahead of time and just reuse that definition. Just like yanked that entire 100 milliseconds out and saved a third of like shaved 30% off their training time. And so that's the kind of insight, like you can maybe see it at the level of kernel utilization, which is the usual kind of metric people look at, but diagnosing it requires looking at traces and profiles to be like, oh, aha, here's a surprising like place where time is being spent, and this is what's going on when those kernels aren't being utilized.
Is amazing. I think it's a really amazing topic. I feel like this is the thing that really separates these like super valuable AI companies. And I think a lot about training embedding models, and I think kind of two perspectives of like how you initialize the loss function. Yeah, like you might create a class. The loss function is something that people do with these with the contrastive loss and how you build that in. I think also just like the data loaders and how you're going to sample the positive negative pairs, and
Mhm.
I think there's probably just a crazy amount of opportunity to optimize these kind of things. But yeah, I think that was a really, really interesting discussion. But I want to kind of step back into a more high level space, and maybe if you could tell
Mhm.
me about your experience with building the full stack deep learning Discord Q&A bot.
Oh yeah, yeah, um, yeah. So I put that together. So what is this thing? It's Q&A over full stack deep learning, the course, full stack LLM bootcamp, and then also my LLM paper lit review Notion database. So all of those are our sources, and we got some YouTube videos, we got some web pages, we got some PDFs, and it's basically like natural language search over those documents, natural language question answering over those documents. And I first built it back in January for the Scale AI hackathon, which was a really sort of like fun. There's now like a hackathon every 2 hours in San Francisco on generative AI. Yeah, got a text from a friend like, "Oh, do you want to go to this hackathon tonight?" I'm like, "Unfortunately, I'm going to a different hackathon like 3 blocks away." But yeah, this was back in January. They had this hackathon, and I was like, well, what can we do right now? Q&A was starting to emerge, and like retrieval augmentation was starting to emerge as like a common application pattern. And the and so it was like clear it could be done pretty straightforwardly. And we get a lot of questions in our Discord where it's like, oh, let me point you to this lecture where we talked about that. Or, oh, here's the paper that's relevant to that question. And it's like, oh, I'd love to automate away that part of my job, so that I leave, like, if there's a super interesting question, maybe I can follow up on it. Or if the question isn't easily answerable, I can follow up on it. So that was like the vision, and it was possible to put together like a very jank demo in like an hour, and then to have like an actually decent UX by the end of the hackathon. Like it had embeds, and I want to say I even also shipped the like give emoji feedback feature of like thumbs up, thumbs down
Mm.
within the hackathon. But the GitHub history can tell you whether I'm lying at this point or not. Uh, but but yeah, so then that is we've stuck with that. We've continued to run it, and it's sort of one place where I get some experience with like what is it like to have one of these things running in production. So like
Mm.
on the delightful side, when I switched it over to GPT-4, I got a ton smarter, and also it's now multilingual. So I woke up one morning to find that somebody had been asking questions about Gradio in Swahili, and from what I could tell, as a non-speaker of Swahili, just using Google Translate and ChatGPT, it was responding in fluent Swahili with like correct answers and sources and links to my videos. That's there's like delightful experiences of users discovering features of these models and ways to use the application I wouldn't have anticipated. And then there's also the sadder parts where it's like, oh geez, like it sometimes just like completely makes shit up. And like sometimes users ask it really weird stuff and it responds in a weird way back to them. And oh yeah, and sometimes it goes down. Sometimes OpenAI goes down. Sometimes Modal goes down. Like yeah, it turns out it's interacting with a database is hard, and the code you write in an hour is not good code for interacting with a database. So those kinds of discoveries, how exactly that happens in the LLM workflow, have also come out of sort of running this thing.
I think the first question I want to ask you about this is, as a content creator, and I feel like that's kind of the mutual bond we share is making deep learning content for a long time and, understanding sort of the, like how you try to grab everyone's attention and all that kind of good stuff.
Mm-hmm.
is like this ability to, you know, automate the content creator, turn the content creator into this artifact. I mean, you mentioned sometimes you get bad responses, but it's like it seems like this will just completely change how we think right now of content creators. Like, I don't know, Mr. Beast is like I don't know if he's a good example of one, but like, educators, people who I think Thomas Frank is a YouTuber famous for Notion tutorials or like general
Mhm.
lifestyle advice, and so it's like
Mhm.
turning himself into a chatbot.
Yeah.
Surely this will change just social media broadly, right?
Yeah, that's an interesting idea. I think, yeah, framing it as like automating myself is more fun and cute than it is like a legitimate statement of what these things are capable of. I
Mm.
definitely have been, I've been experimenting with with audio generation with UberDuck and 11 Labs to like generate things that sound like me on a podcast. I promise I'm not using that right now. I don't know how I can prove it to anybody listening to this.
Yeah.
But the so like there definitely seem to be some pieces that are there, but like full end to end automation is always challenging, right? If you look even at like very sophisticated software shops, there are limits to what they're able to automate, even in this like in principle halcyon world of software where everything is bits flowing through machines that should behave deterministically.
Mhm.
And so I would say I'm bearish on in the short term on things like fully automating yourself, but finding ways to like take things that you are doing with your time that are low value, that are repetitive but context dependent, or like require interfacing with natural language, um, you know, uh, that are in the end like kind of low effort things that you are doing, taking those and replacing them so that you then take that time you're spending on that and then can re-index onto the higher effort stuff. That feels like a more that's like achievable right now. Like there are wins you can find right now for that, and so that's how I'm my current mental model for it. The point at which content creators are defined as points within embedding space plus a small neighborhood. Um, you know that feels fairly far away.
Yeah, I guess it's just like I think about, yeah, exactly like you say, like the automating the more, repetitive low level tasks to let you think in higher levels of abstraction is like always amazing. I just think also kind of like the like you mentioned, the how do I fix this Gradio bug in Swahili? Like I think the way it unlocks the global market, it also can create like hyper competitiveness now because like, the top 5% can also scale, like they can
Mhm.
deliver the personal touch that through the language models and stuff like that.
Yeah,
And yeah, so I guess I just feel like the content creators have access. The market is growing, and yeah,
definitely. And yeah, I would say it's like people already from the like last generation of machine learning people this idea of like drudgery or certain kinds of like menial tasks could be automated, and like many of them could have been automated with a spreadsheet, much less BERT, much less GPT-4. But there's also the you suggested this initially as like a content creator automating themselves as a chatbot. That is like that's maybe not the same thing as like full automation, like full replacement of
Mhm.
the role
Mhm.
served by a content creator with a machine, but it is like a much less machine like thing that people were doing, which is like interacting with a person, understanding what they want and trying to give them what they want. It's just that often when you are doing that, you only need to do it at a very like superficial level, or it's once you have the context of the document that has the answer, it's like as straightforward as copy pasting with a little bit of editing. Like that's much further along the spectrum from what we think of as machines to what we think of as labor for machines to what we think of as labor for humans. And so definitely there is a push in that direction from highly capable language models.
Yeah, I agree 100%. I think like there's this other concept of like the language models that produce the novel content, like the language model, through maybe retrieval augmented generation, where it like retrieves this part of the passage as part of this, tries to come up with like novel insights. I don't know exactly like, but like you tune the language model, however it does this, it produces some kind of blog post. And that
Hmm.
makes me think even more of the power of like your personal brand, because it's like as the content platforms become flooded with this kind of content, it's like that Charles tweeted it, that, or however the medium platform, that's like what that stamp of human brand is going to be so valuable.
Yeah, I would say the essential postmodern artist is the DJ whose artistry is in
Yeah.
taste and selection and presentation of what a previous mode of productions artists created. And it with language models, perhaps we can effectively all become DJs of text, mixing together things generated by models, with maybe just adding a nice light four on the floor beat underneath them as we mix them together.
Yeah, I mean, like for me, my opportunity has mostly been not in producing novel papers, but more in just echoing what I find is interesting, and like that's through experimenting with the algorithms and what is successful. Like if I review like a paper from Sergey Levine on offline reinforcement learning, that's gonna do better than me just saying, "Hey, these are just my thoughts on this topic." Yeah. So I wanted to ask you also a technical question about this, which
Mhm.
is you mentioned Notion page, YouTube, the official course material. You have these different sources of data, and then you put it into like a vector database. How do you think about like the schema design for different sources? Do you have like a, yeah?
Well, I've been using MongoDB for my level of storage, which is a commitment to not have a schema.
Mhm.
The you can have a loose an application layer defined schema, which is easier than a database layer defined schema. But the real thing there is it's like still figuring out what exactly does this look like, what must it have, what might it have in a document. Um, yeah, I would say like your questions when you have like multiple sources,
Mhm.
if you there's like a certain scale at which you can no longer be very precious about your handling of sources and you have to be very generic. I think you end up getting like worse results if all you're doing is saying like documents are going to be like annotated with what are their H1 and H2 headings, but like coming from Markdown or HTML. But that means something very different in different websites. Like it has a particular meaning. Like H2 has a particular meaning inside of our online course notes, but that's like not what it means on some other page. And Yeah, we have chapters in our YouTube videos. I use the chapters as like metadata during processing and later. And that's also like chapters can have different meanings when you're consuming different types of YouTube videos. And like that, like injecting a little bit of knowledge there can go a long way to increasing the quality of generations. And fundamentally, like why do we have this? It's because we need to take documents that are longer than the context length and eventually get them down to the context length. And you want to start, I think, with like splitting up your documents at their joints, like splitting them up by sensible like ways to split them, chapters, headings, whatever subdocument type thing. And then only after that, when it's time to decide what's going to go into the language model, do you actually chunk it to something smaller, like maybe a few hundred tokens at a time. But you this makes sure you don't cut across any like really serious seams in your document. So like that's one of the like primary things to think about. And then I guess the other thing at sort of like a application architecture kind of level is like I think of the like embedding vectors and vector storage as an index into this information. So an index in a database is something like we've already stored the data and then we add an index, right? So we might add an index that's prefix regex based. And this is it like pre-computes a bunch of stuff for us and stores it in a data structure that then allows us to make certain queries really, really fast. And that's effectively how like every application that I have used and like embeddings for has been to do that. And like when you think of a database, it's about a lot more than just like an index. It's like I want to version these things. Maybe I want time travel. Maybe I want stored procedures. Like it's a whole bunch of other stuff. Um, and so vector storage like feels as I have used it in a RAG pipeline a lot more like an index. Um, and so like you kind of want to separate out this is the current state of this document corpus, maybe split into subdocuments. This is the current state of it. And then this is the index over it using a particular strategy of chunking, a particular embedding model, whatever, that then is what the application directly touches. Um,
Yeah, I think like my current understanding is that the best way to do this would be to have one class for just text chunks, like every chunk from every source, however long it ends up being, like 100 tokens, or you max it out at the 512 tokens, all lives in one vector index with symbolic properties for like
mm,
Notion, YouTube, or like title if the page has such a thing. And then so from that one index where you build one HNSW graph with like, however much you have possibly, you also kind of would add that extra structure in separate classes. So like,
mm,
like this is like the master chunk class, and then you have like the Notion class or like the YouTube class.
mm,
I kind of think like that kind of symbolic separation is the best way. And then you can kind of like, we have this one thing in Weaviate that's called the group by filter, where it's like
mm,
a book has like let's say we have two different books and one has 10 chunks, another has 8 that match our query, like in the top 100 of our query.
mm,
So you would group it and then you would rank the at the book level based on how many passages have matched it. So I think that's like one way of just using metadata again in search that we talked about earlier again. But
mm,
there's this other idea of like maybe using graph structure to flow embeddings through the graph. It's kind of like a knowledge graph idea, or like maybe like graph convolutional networks that would
mm,
like take each chunk and use its kind of context in the graph of like, blog post cites this other blog post in addition to just this kind of like where it's sourced from, in addition its relation to other things. I just think there's like some cool things we can do by thinking further about this. I'm sorry if that's not too concrete, but
No, yeah, I don't know as much about the knowledge graph world and the graph database world. I think like definitely and like people in NLP have been thinking a lot about this. It feels to me a lot like the branch of NLP that has been like basically obliterated by the rise of large language models. But that doesn't mean they can't have a triumphant return. So I have definitely talked with some people who are thinking about knowledge graph approaches, and um, yeah, I can see that working pretty well for being like, oh, what are related documents? Maybe they don't embed the same. Maybe they are semantically very different from the perspective of the embedding, but they're related by this graph. And that's that kind of link based ranking is obviously very good for search, or else
Mhm.
uh, yeah, I wouldn't have been using Gmail to communicate with you about a Google Meet. But
Yeah.
but yeah, so yeah, I see. Yeah, the thing that I said about like there's an index and a separate document store, like that. You can enhance that a lot by creating a full on database with integrated search that uses metadata. That metadata is used to construct indices that have both like a vector HNSW type index, but also have the metadata as like additional flags that are used to construct indices that allow like very rapid querying on subcomponents.
Yeah, I guess just like broadly, like with this topic, I think that there is a really interesting opportunity for vector databases and graph databases to be used together more. I think the low hanging fruit is you totally separate them entirely, and you think of a graph database more in like the graph analytics kind of way. Like think about like a Twitter like graph, like Connor like Charles's tweet, that kind of graph where you then compute like page rank kind of
Mhm.
centrality metrics for like a particular tweet, and then you use that as a feature for re-ranking, where that's like one of the tabular features for XGBoost. Yeah, and like so, I think that's the most low hanging fruit. But I don't know. Like there's another idea like deep walk node to vec where you like walk along the graph to find the
Hmm.
positives and negatives for the
Hmm.
contrastive optimization. But
Hmm. Yeah, definitely. I mean, there was some interesting. I want to say it was a blog post, but at the very least, it was like a Twitter thread. Like LangChain has started to incorporate some graph databases and is starting to think about like graph databases as tools. Like
mhm.
there's, graph databases have not been as successful as maybe you might have predicted in 2015 at the height of NoSQL and social media. You might have been like, graph databases are gonna replace SQL, and like it's the only thing anybody will ever use. And that's like the opposite has happened. Like SQL databases have gotten better at storing graphs and gotten better at storing documents and other things. But the at the bare minimum, representing graph structures inside of databases and using that as part of the querying, searching, ranking process, very clearly a ton of opportunity there.
Yeah, yeah. So it's so I have so many different ways of just conceptualizing this in my head. Like you
Mm-hmm.
could be talking about like a neighborhood of houses, something where there's like a graph structure that maybe you embed into a vector, or like a molecule where you embed that graph structure into a vector, or it could, yeah, or the graph is itself like something that you derive out to contextualize the vector. And yeah,
Mm. Yeah.
yeah, I just think like I don't know. There was this one paper I saw that was called Prime KG from Harvard Biomedical Informatics Institute that was like disease drug target relations, and then each one has like unstructured text data about it that's using an embedding, and there's like something about classifying subgraphs as well that are like affiliated with some particular like metabolic pathway. Like there's just
Mm.
something to this, and the reason I'm trying to connect this back with the Discord bot is I also like to think about like I have a Weaviate podcast transcriptions data set that you'll soon be in, Charles, and like
Nice.
I like to build a graph of this with the Weaviate blogs and the Weaviate documentation, and I'm thinking like, how do I design this data schema? And that's kind of what I've settled on now is like I just have the chunk masterclass, and then I have links to these kind of podcast transcripts, blogs like separate. They have their own index as well, but this master thing is really where the meat of it is.
Interesting.
Because I mean, just yeah, it's just pretty. I think pretty interesting thinking about the data schema with that. With like you can use symbolic properties to filter your search through it, but it's yeah, I don't know. It's just like digging into it further.
Yeah.
Yeah.
Yeah. There's definitely a lot there, and I'm sure. Yeah, the people coming from the ML world have a lot to learn from the people who've been thinking about search and retrieval with and without ML involved at all. And yeah, part of what is exciting about this moment of like rapid iteration and rapid building of like full stack applications is that now people from all kinds of different disciplines of software are looking at this, paying attention to it, and being like, wait a second, I recognize that pattern. That's what we've been doing for 30 years. You're still doing the dumb version of it. Let me give you the benefit of like 3 decades of thinking about this problem. Here's concentrated nuggets of better ways to do things. And so you can see that sort of like happening with with retrieval, with tool use, with language models for code generation, with UX and design, with constructing defensible businesses and thinking about the whole business around the features or products you're building with language models. Yeah.
Amazing. Well, Charles, I'm so happy with our coverage of the full stack deep learning. I think we really, explaining kind of the zero shot MVP, get started, iterate on the UX instead of the model, and then this data engine, what might be the middleware for realizing that? Is it worth realizing it? And all the nuance. I think it was such a great coverage. Let me kind of wrapping up this podcast, ask you like a broad question of like some of the directions for the future. I know this question can kind of put people on the spot. It's like, what, predict the future, but like, what is maybe not necessarily something that it could be something that just like you can answer this however you like, of course, but like whether it's something that you just want to see happen, like LLM inference costs like nothing basically, or it could
Mhm.
be, I don't know, just like a dream, like just what you. Oh, sorry, or it could be something that you just think very practically. This is just the force is headed in this direction. So kind of like dreaming or practically however you want to take the question.
Yeah. I appreciate the breadth of question.
Yeah.
Yeah. I'd say that thinking on, let's call it like, yeah, on like a 1 to 3 year time scale, the phenomena that I think are most important are the decreasing cost of inference and the incorporation and multimodality
Mm.
and and like maybe the longer end of the like 3 years up to maybe 5 years, the combination of those two things unlocking um, applications in robotics.
Mm.
So cost of inference is going down. Like it's just we're in like a super Moore's law, like with the cost of cognitive capabilities. Like you set some benchmark of like I want to be able to do at least these 10 things with a model, and then you can just watch that plummet. The cost just absolutely plummet. I think the ADA embeddings from OpenAI have gone down by probably 10x since like November. And like like with GPT 3 to Turbo, that was or 3.5 to 3.5 Turbo, like that was a 10x reduction in cost in like 6 months or something. And they're not done. So that is, I expect that phenomenon to continue. There's competitive pressure, there's hardware innovation, there's all the work being done to get like things down to int3 inference and, and shrink these things down, put them on consumer cards. There's just like, and like always the dark horse of like specialized accelerators. Um, and like people can just like, you know, the architecture's been fixed for long enough, the like attention has been on that for long enough, people can just like really just keep cranking that number down. And we have seen while retaining like the same level of capabilities. So I would expect the like we're just going to continue to see the cost of inference going down. Obviously, we'll continue to push the frontier of capabilities, and so the frontier of capabilities might always cost like the same amount, or might go up in cost to get the frontier of capabilities. But those capabilities are always they're moving up. It's like you have to be in the right reference frame to think about this. And so, in a future where it is like GPT 3.5 Turbo capabilities are 10x cheaper in a year and then 50x cheaper in 2 years. Like that's a different world than the one we're in right now. So I've had people ask me like, when am I going to get ChatGPT NPCs in my video games? And it's like, not today, unless you're willing to shell out like $1 a minute to play a video game. But $1 a minute becomes like a penny a minute in like 2 or 3 years, and that's like very, very like people like that unlocks applications of these models that are currently blocked. I think you know multimodality is one of those things that we are getting into smaller and smaller models. We're getting into higher quality and faster inference. Oplan Flamingo V2 came out like within the last week of this recording, and that's like an improved multimodal model. People have been finding better and better ways to do image language multimodality, and those models, as mentioned earlier, like the GPT-4 self-driving example, like you unlock a lot of transfer learning opportunities between image and vision that make the image models or the vision models, the image models or the language models both better. And so the trend that brings those two things together that I'm excited about on this time horizon is robotics, the general discipline in which self-driving technically should be put. Where if you can run GPT 3.5 Turbo in milliseconds for, on something that's drawing 10 watts of power, then you have yourself like a robot that you can talk to deliver commands, so long as that language model can interface with the robot body as like one of its tools, perhaps via lower level reinforcement learning style policies. That's just like we don't have general purpose robots for a number of reasons, but in a couple of years, they can't be smart enough and they aren't as easy to interact with when they're doing tasks as humans. That excuse is gone. The servos and the what do you do when it swings around and breaks somebody's nose? Those kinds of questions, maintenance, those questions remain hard, but not the intelligence.
Yeah, super compelling picture for the future. Inspired by all those things as well. I think with the maybe one thing to stay on. I mean, I think this kind of like NPCs in video games with super cheap LLMs. One idea that's always stuck with me that I find to be really fascinating is I had Yu Sheng Wu on the podcast who discussed Chat Arena, where it's like, Charles and Connor speaking in simulated conversations, like a million simulated conversations between us, and like this idea of just like creating this, like, I like to think of it as we take generative models and we create the output space by sampling from them, and then we use vector search to look in that the latent space of that generated output space to see like, is any of the like now is like more to search through or something like that. I don't.
Interesting. Yeah, definitely language models are useful for their ability to allow us to like explore language. um, like
Yeah.
people focus a lot on the practical applications. People focus on like, oh, I can use the fact that this generates language and requires language as one of its expensive inputs to like accelerate and amplify. But those are like downstream of this like fundamental thing, which is we now have machines that are like capable explorers of language space, capable
Hmm.
producers of utterances, like
Hmm.
yeah, and that is maybe like very long term, at the scale of like decades, probably a very interesting phenomenon about language models. How does it change the way that we speak? How does it change the way that we interact with language? That now that the production and exploration of language is no longer bottlenecked on a human being um,
Hmm.
producing.
Yeah, it's fascinating. Yeah, I think like there's this thing that one of the big dangers of language models is that they're so persuasive that you like, similar to how a recommendation engine now is already kind of persuasive for extreme ideas by like keeping you in that interest. That bit, yeah, yeah, the whole exploring the language space. I love thinking about that, and then also like when you draw that to code as well, how it can like explore the space of what code can do by writing all sorts of code, and you have to have abstractions that you share with other LLM programmers, and they're like, okay, I like this abstraction. Yeah,
Yeah.
yeah,
Yeah,
epic.
we've barely begun to see what the impact of these things on programming is going to be, right?
Mhm.
Yeah, changes in technologies produced by programming, like reflect back and change programming languages. So like the rise of developer tooling, like really, really high quality developer in editor developer tooling is changing the way people think about languages. Like Rust would not be nearly as easy and fun, at least in the good times, to write, were it not for like the various forms of like IntelliSense, code completion, like the compiler and the analyzer are like directly interfacing with the document. Like if I had to write it on a punch card, or like write it in a static document, hand it off to compiler,
Yeah.
then get back an error message, as opposed to this is
Mhm.
the type I'm inferring, you get it on hover. Like that has already changed the behavior of languages. Python is getting typing over its own dead body. but and that's part of that is because people love this developer experience of being able to like see those things. And previously, the fact that Python didn't have types was like its selling point. And that's just some very humdrum technological changes around like the like language server protocol and like improvements in in developer environments and text editors. So to imagine, yeah, what's possible now that production of semantically meaningful text is not bottlenecked on humans. I think we'll see some pretty rad programming languages in like a 10 to 20 year timeline.
Yeah, amazing. And that's a funny. Like, I also like came into Python. Like, I remember the JavaScript. Like, you don't have to write the types. And I was like, oh, nice. And then that was like TypeScript. It's like, oh no, it's back. I have to write
Yeah.
TypeScript. Yeah. But yeah. Charles, thank you so much for joining the Weaviate podcast. This is truly one of my favorite podcasts. We covered so many topics and I learned so much. Thank you so much.
Yeah, thanks so much for having me, Connor. This was a blast.